Okay, so now you're going to learn how to use GeoGebra to make a few constructions, some basic constructions. So you might remember that down here on your dock in your Chromebook, you have this little app right here that's for GeoGebra. If you click that, it'll launch a window in your Chrome browser and it'll load up GeoGebra. So clicking on that will load this. This is GeoGebra right here. Okay, now basically in GeoGebra you're going to learn that, it's a funny name and it kind of stands for geometry and algebra. And the reason for it is in algebra you learn coordinates. This is the coordinate plane. You learn the x and the y axis, and you learn the representations for it. So if I give you an ordered pair like 2, 1, you know that means the x value is 2, the y value is 1, and there should be a point that exists in the plane. That's the algebra over here. And in geometry, we deal more with figures that are in the plane. So we can create the figures over here and look back and see what the algebra is, or we can work the other way around. So let me start by putting in that point. If I said, A equals, now I have to use a capital A so that it knows that I'm talking about a point. If I use a lowercase a, it'll think I'm talking about a vector, which is something you'll learn about later on. So capital A equals, open parentheses, 2, 1, close parentheses, and enter. You can see that I've typed an input here. It created a point at 2, 1. And then the graphic side over here shows us the geometric representation of that point. So there's a connection, right? Everything we see can be mapped out and there can be an algebraic explanation for it. Let's try a line real quick. You I'm sure used lines like this. Y equals, let's say negative 3x plus 2. That's the line that you will see, has a y-intercept of positive 2 and a slope of negative 3 over 1, so it goes down 3 over 1. And that's the algebraic representation here, and here is the graphic representation of it over here. So, that's one way that you can input. Since you've already learned things in algebra, anything that you've learned, you can create over here. I'll make one more. It's a parabola, and I'll do y equals, let's say 2, open parentheses, x minus, let's say 3, close parentheses, squared. You notice I'm going to put the shift 6, that gives that little arrow right there, shift 6, and then squared, and then I'll hit a space and go minus 2. So this is the vertex form of a quadratic equation, which you may remember from Algebra 1, the second semester. But basically what we're doing here is we are making a conic, which is a bent shape, right? And it's actually what it is, a parabola, okay, with a vertex at x equals positive 3 and y equals negative 2. And then it is going to open upwards. That's the positive coefficient here. So when I hit enter, we see there it is. At positive 3, negative 2 is the vertex, and it opens upward like that. So, and it shows up as a conic. That's a classification of a form of a line, right? In this case, it is a parabola. And you're going to learn a lot about parabolas in this class. So there's the input side. The other thing that you can do, and this is really what you want to practice doing, because you'll do more of this in this class than the other, is you're going to use these menus up here. And you're going to need to take some time and just kind of explore the menus a little bit. The first set of menus here I'm just going to show you really quickly, but for placing points in the plane. We won't use complex numbers. That doesn't come in until Algebra 2. But you are going to use a lot of these tools right here, in particular midpoint centers, intersection points, placing points on the object, and just placing a new point. So when you use the new point tool, anywhere you click, you create points. And you can see that the algebra shows up for that point over here. There's the exact coordinates of point B. Okay, this is the move tool. So once I've created a point, if I want to change it, I can slide it around and move it, and I'll just park it at 3, 4. You can see as I moved it, now that it's at 3, 4, the coordinates are there. And so, pretty much a lot of things can be moved. If you have a point on the conic, let's place a point on the conic, it will not come off, okay, or a point on a line. So let's go ahead and place a point on, we're using the point on object, and I'm going to select line A. And now we have point E, which is on line A, right, this line right here. And you'll notice that when I drag, I can't pull it off. It'll come down and up, right, but it has to stay on the line. If I place one on my parabola right here, there's point F. As I slide around, it'll move around the parabola, but it will not come off. So that's what the point on tool does. So now let me change here a little bit. My line, if I right mouse click here, I can hit my my object properties, and then there under the definition I can change it, and let me make that just with a positive slope so that we get an intersection. So it's y equals 3x plus 2 now. So if I close that, I can see it's now still got the same intercept at positive 2, but now it has a slope that goes up 3 and over 1. So now I want to find that point where they intersect. That would be this point right here. This is an intersection of two objects. And I can click the first object here and the second object there, and there's the intersection. Actually, this one over here is the button that you would use to move things. So I can click it and then click and drag. And eventually, if I really dragged, I'd see, hey, that intersected the parabola in two different places, at G and H. And the solutions, or the coordinates of those 2 points are right there, okay? Okay, so that's basically, how you'd use the points menu. You can also make lines using either points that already were defined or just pick 2 new points. You can make a segment, so that has, it's like a line with an endpoint. So here I'm making the segment that connects A and D. Notice when I made the segment over here, what it did was it measured it for me automatically, gave me the length of that segment automatically right here. Okay, these lines that I just drew, okay, they are lines, but they're in standard form. But maybe I want to see the equation in slope-intercept form, so I can come over here and change it to y equals mx plus b form. Click like that. Now I can see the intercept and the slope of that line. And I can do the same thing here. Okay? So anyway, I can make lots of different things here, right? I can do an array, right? Has a beginning point at k, and I can define, L wherever. If I come here, I can move L, right, and change the ray that way. I can move K and change the ray that way, right, using my move tool. We'll just kind of stop there for a minute. This tool here, this button, is for my constructions, and constructions are kind of a big deal, right? So, in this task, you will be making in this adventure some perpendicular lines or some other constructions, perpendiculars, parallels, etc. Let's start with a perpendicular line. Let's say I wanted to be perpendicular to this line segment. So when I hover over here, it'll tell me what I'm supposed to do. Notice it says select point and perpendicular line. That's what the instructions say right there. Select a point and a perpendicular line. So what I'm going to do is I'm going to select, I can go in this order. I can just say, let me go through this segment. So see how it's going to be perpendicular, and then I select the point I want it to run through. So now I have created a perpendicular that is perpendicular to this segment and runs through point B. We'll do it again. There it goes through point C. Here's another perpendicular that goes through point J. And as you can tell, there's going to be tons of perpendiculars that would go through this segment alone. Okay? I can do that for any segment, create a perpendicular, and then just select the point that I want it to run through. It's starting to get really messy, right? So parallel lines work very much the same way. I want to be parallel to this but run through B, and I'm going to leave you to kind of practice with this. You can see angle bisectors, tangents. We won't get into this down here in this class, but perpendicular bisectors and angle bisectors and tangents are the ones. These are the ones you're most going to get into in here. Okay, next tool is for shapes, polygons. We're going to work with. So here we have a traditional or non-traditional triangle. So a polygon can be created by just selecting the vertices and then just returning to the first vertex, and then it'll solidify, and over here it'll certainly say that your first polygon is classified as a triangle, There it is. And that number there is giving me the area of the triangle. Okay. So then the next one is, let's see, a regular polygon. Now, regular polygons you're going to learn, and we are definitely going to need to know this. But a regular polygon is a special polygon that has exactly the same measures on every side and every angle. So let's try a regular hexagon. So I would select the 2 points when I'm using this tool, select the 2 points, and then tell how many vertices this should have. And I'm going to say it has 6 vertices. So I'm going to click OK. There I have it. And this is exactly the same length on an angle measure on every side. So now what would happen if I change this? Well, you know, see, I'm using my move tool. So I can grab this second point Q and it changes the size of each side. Or I can grab P and do the same. Okay, so if I want to, I can move my thing there. Okay, then we have the rigid polygon tool. And this basically clones your original tool, so our original polygon. Notice if I want to select this polygon right here, which is the triangle, and if I hover over it, you can see it tells me it's triangle poly 1. So I can come over here, I can find it. I can either click on it when it says triangle poly 1, or I can just click over here. And when I did, it created triangle. This will be triangle poly 3. So it's the third polygon. It's a second triangle here. There was my second polygon, poly 2, right there, the hexagon. And here is the triangle poly 3. And it is a rigid tool, so what that means is that it has made a rigid copy. If you look at the end there, it says select all vertices, then click first vertex again, or you can just click on the polygon to make a rigid copy. So we just made a copy of triangle MNO, and that's going to be triangle VWZ. Over here we can't see Z. I can see over here that it is not marked, so I'm going to mark it here, Z. All right, circle tools are in here. I'm going to have you explore that a little bit, and I'm not going to have you worry just yet about reflections or anything, just constructions. You're just making points, segments, lines, maybe some polygons, and then constructing perpendiculars and bisectors, right? You can find segment bisectors. You can bisect a segment with a midpoint tool. So let's find the midpoint of that segment. There it is. And you can, use your different constructions here. The next thing you have to know is how to share that. So I'm going to click File, and I'm going to click Share. So it's going to upload it once I've done that to Geogebratube, and it automatically takes me to Geogebratube.org. Now I find that I have to log in and then do that again. So I'm going to click Log In so that I'm signed in. It says use an account. I'm going to use my Google account to sign in, and it asks me which Google account. That's my CHS Google account. So now that I'm logged in, it's going to ask me what is this that I'm sharing, and I have to put some information in here. It will not share. There's everything I just created. So this is a sample of constructions in the plane, I'll just say. Okay, and then we're going to go back here, and it says, do you want to include questions or tasks? And I'm going to not include any. I'm just going to hit continue, and then the next thing it says, do you want to put a title on here? So this is my evidence from adventure 3, and the description includes segments, rays, conics, polygons, and bisectors, and parallels and perpendiculars. Something like that. That'll work. My language, I'll select English US, and you have to put tags down here, so I'll just put geometry down as a tag. There it is. And I'm going to make it shared with a link. As long as I select shared with a link, and then I can click save, and we're going to wait a minute, and it should save here in a moment. And it says my material successfully created, and now if I want to share it, I click share, and it gives me this link. So guess what I'm going to do with that link? I can highlight it and copy that link address, or I can click copy to clipboard. And when I go into my live binder, I can actually paste that into my live binder and it'll be embedded in my binder as my evidence. That's it.